Hello, students! Today we are diving into one of the most essential and powerful topic, so exponentials and logarithms. And let's get started. Problem number one. A bacteria culture starts with 200 bacteria and doubles every 4 hours. In A, we have to write a function for the number of bacteria after t hours. We know that n versus t is the number of bacteria after t hours, and our initial number of bacteria is 200, and this amount doubles every 4 hours. And now we have to recognize that our function for the number of bacteria after t hours is exponential because it shows exponential pattern. So it will look like this. If you forget how the exponential function looks like, you can simply check it on your GDC because there you have every type of function, so you can simply check it. And now the most important thing, so our n versus t equals. Firstly, we have to write our initial number of bacteria, so 200, and it doubles every 4 hours. So it doubles every 4 hours. So we can leave here t, and we can simplify it by substituting just 400 in here, because we know that doubled 200 is simply 400. So it is something like this, and we have to substitute here 1, because 2 to the power of 1 it's just 2, and 2 times 200 is 400. But if our t is 1, we have to also include the information that our number of bacteria doubles every 4 hours. So our 1 can be also written as 4 over 4. So from this point of view, we can substitute it into our function. So 200 stays the same because it's our initial number of bacteria, it doesn't change, times 2, and we don't have 400 in here anymore, because we need to write this function for any other amount and any other time. So we simply need to leave here t over 4. And you can see, if we substitute 4 into t, we will have 400. If we substitute any other number, for example 8, 12, 16, 20, you will see that our number of bacteria will double every this given amount of time. So we can check it, you can check it by your own and see that it will be always true. And if anyone get lost in here, this was for me, this was the easiest way to find it, because we have 1 from this, and 4 over 4 is just 1. And we have that it doubles every 4 hours, and we used 4 hours just to check it. So it was our number, but it will change because of any other amount of time. But this stays the same because it is constant, because it doubles every 4 hours, and this was our amount of time that we have checked for this exercise. And in B, we simply need to find how many bacteria will there be after 12 hours. So our T is 12 because it's our time in hours, and N equals 200 times 2. Here we have 12 because it's T, 12 over 4, so simplifying it, it's 200 times 2 to the power of 3, and it's simply 1600 bacteria. In problem number 2, we have to use the function that is given, firstly to complete the table for x's. So we can write our table and then write corresponding y's to our x's. It looks like this, and you can simply calculate it by typing it into your GDC or simple calculator and complete the table. In point B, we have to sketch the graph. So this is our graph, and you can graph it simply by typing our function into your GDC, or just by using the table, plotting dots, and then graphing the whole function. And in C, we have to state the horizontal asymptote and y-intercept. So we can start from y-intercept. This means we are looking for the point where our function crosses with y-axis, and we can see that this is here. So this is 0, 1, because on x's it is 0 and on y's it's 1. And now we have to state the horizontal asymptote. Horizontal asymptote means that if it's horizontal, it's for sure a horizontal line, and asymptote means the line which will not be crossed by our function. And we can see that our function here will be smaller, 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 and smaller, and will not cross this line, which is also x-axis. So our horizontal asymptote, it's just y equals 0, because in here our y is 0, and if you are not sure whether this function will cross or not cross this x-axis, you can check it on your GDC by plotting the function, and you can check for example, x equals minus 100, what is the number, if it is positive or negative. Next problem just checks if you can correctly type these logarithms and one natural logarithm into your GDC. So I will write the answers, and you can check if you have the same answers. Okay, so here are the answers. We have them from our GDC, but we can also highlight It's not necessary for this exercise, but for more advanced exercises, it may be crucial to know the rules of logarithms. And in A, we have logarithm with a base of 10, and in bracket we have 1000. So 10 to the power of something equals 1000. So 10 to the power of 3 equals 1000. In B, we have natural logarithm, and natural logarithm always cancel out with the letter E. So what stays is the number 5. And in C, we have 10 to the power of something equals 0.01. So 10 to the power of minus 2 equals 0.01, and we can simply calculate it also in solver. Problem number 4. A phone loses 30% of its value every year. It was bought for $1,200. And in A, write an exponential decay function. So we have to write this function. And like in the first problem, we can start with our initial value. So 1,200 times if the phone loses 30%, so the rest amount is 70%. So we can write it like this, and to the power of t. However, if you are not sure how to write an exponential decay function for this problem, we can simply use compound interest and derive this function from compound interest. This is the formula that you have in your booklet, and we can use it to find our exponential decay function. So our future value will be v, because we are looking for it. Our present value is 1,200 times 1 stays the same, and here we have to remember that if we have decay or depreciation or devaluation, we have to change our positive sign, so plus, into negative sign, so minus, and r is just 30. We have here 100. K is compound interest, so when we have growth or decay function, we don't write it, it's just 1. And here we have K, so also compound interest, so it's 1. And N, we are substituting different time, so time stays as t. And if we simplify it, you will see that it is the same. And in B, we have to estimate the value after 3 years, so our v is 3, so v equals 1,200 times 0.7 to the power of 3, and we have to calculate it. So it is 411.6, and if we want to round it to the 3 significant figures, it is 412. In problem 5, we have to solve this equation, and we can solve it simply by typing it into our solver on our GDC. However, there is important thing that we have to give our answer to 3 dp, and dp always stays for decimal places. So 3 numbers after our dot. And if you calculated it correctly, our x equals to 1.609. So 3 numbers after dot, these are decimal places. In problem 6, we have to also calculate. We can calculate it directly on our GDC, but it is stated that we have to simplify firstly and evaluate. So, firstly, we have to simplify it knowing the log laws. So, our natural logarithm, and in a bracket we have 3e to the power of 2, and using our laws of logarithms that you should know, it is natural logarithm of 3 plus natural logarithm of e to the power of 2. So if we have multiplication in natural logarithm between two numbers, because e is also a number, we can write it like this, as the sum of two natural logarithms, and we know that natural logarithm and e always cancel out, so we have natural logarithm and 3 in a bracket plus 2, because if natural logarithm and e cancel, if they cancel out, we have this power as a number, and then we can calculate it on our GDC. And here is our final answer. Now we have problem 7. A virus spreads according to, and we have our function. And firstly, we have to find how many people are infected after 7 days. So t is 7, and we just need to substitute it into our function and find the answer. And this is our answer. I know that we have people, so it cannot be half of a person, but we can leave it like this. On your final exam, you will be asked, for example, to round it to the whole number. So then you have to round it, but now we can leave it like this. And in point B, we have to calculate days. In A, we were calculating number of people, and now we have to, we will be looking for T. After how many days will the number reach 500? So now our number is 500. So we can simply substitute it into our function. So 500 equals 50 times e to the power of 0.25 times t, and t we can simply find by typing it into solver on our GDC. So our final answer is 9.21 days. In problem 8, we have to solve the equation with logarithms, and we can just use our solver to find x. Our x equals 2.74, and we also need to state any restrictions on the domain, and it is crucial in terms of logarithms because they are always positive numbers. So our domain means that this and this they have to be positive, so greater than 0. So x plus 3 has to be greater than 0, and x minus 1 has to be also greater than 0. So x has to be greater than minus 3, and x has to be greater than 1, and their common part is x greater than 1, so our final domain is x greater than 1. In problem number 9, we have to find the inverse function of our function that is given. So we can rewrite it like this. F of x is the same as y, so we can write it like this. And now to find the inverse function, so we know that in inverse function x is y and y is x. So we can swap x with y, so our function will look like this. And now we have to designate y. So firstly, what we can do is divide both sides by 7. Unfortunately, we cannot solve it in the GDC, so we have to do it this way. So x divided by 7 equals 7 with 7 will cancel out, so we have here e to the power of 3y. And now we remember that natural logarithm multiplied by e, they will always cancel out. So we can multiply both sides by natural logarithm. So we will have something like this. Natural logarithm, in bracket we have x over 7. And on the right side we have natural logarithm multiplied by e to the power of 3y. And it will cancel out. So we have natural logarithm, and on the right side we have 3y, and to have only y we have to divide both sides by 3. So it is the same as multiplying by 1 over 3. So we will multiply it by 1 over 3. So 1 over 3 times natural logarithm x over 7 equals y. So our final answer is 1 over 3 natural logarithm, in bracket we have x over 7, and this is our inverse function. That's all for this topic. If you have any questions, feel free to reach me out in comments or via my mail. You can also leave a thumbs up and subscribe to my channel if you found this video interesting and helpful. And see you in the next video. Bye!